Okay, so we're going to keep writing some equations of polar graphs. So this is number 5 for you. That's on page 145. And this is not a circle. It's an offset circle because you can see the center of the circle is not at the origin, so it's a little shifted over. This is what we call an indented loop. Sometimes one of the sides of the indented loop can appear to be flat, but in this case, it's not really flat, but we're gonna write the equation anyway. So the first thing that we need to talk about is that it's definitely gonna be a cosine equation, and that's because it's centered along the x-axis. And then the next thing we need to do is we're gonna look, I'm looking at page 143, it's an indented loop, so it says that A is gonna be bigger than B for the indented loop. And then we're going to be in the equation R equals A plus or minus B. And then I'm going to use the cosine equation, theta, or cosine, because I'm on the x-axis here. So a couple things. First of all, because the bigger side, and by bigger side I mean the longer side, right here is on the negative axis. I definitely want to use the minus version. So just by looking at the graph and deducing a couple things, we've already decided to cosine. We know we have a minus, and because we know it's an indented loop, the A value has to be bigger than the B value. So on the indented loops, I know you're going to hate me for saying this, it's kind of like a system of 2 linear equations. So if you count this length here, it's 6. And if you count this length here, oops, I went way too far, sorry. And if you count this length here, it's 4. So we're looking for 2 numbers, which we call A and B. A plus B has to add up to equal 6, the bigger side. And then A minus B has to subtract and equal 4. So you can do guess and check, or you can, I'm going to do the algebra because that's who I am. So when you do this and you add these 2 equations together, those b's cancel out. So you get 2a equals 10. So a must equal 5. And then you can plug a back in and say 5 plus what makes 6? Well, b has to be 1. And remember, we're going to check right here. A has to be the bigger number. So a is 5 and b is 1. So the equation of this indented loop is going to be r equals 5 minus 1 cosine theta. Let's try another one. Number 6 is centered about this origin. So this is a perfect circle. And so all we need to do is count what ring it's on. So ring 1, 2, 3. So this is R equals 3. That's the equation. Easy as that. Now, if this circle had not been centered on the origin, then we would have had the R equals cosine. Oh, hang on, I forgot the A out front. We would have had the A cosine theta or the R equals A sine theta. But that's only when the center is not at the origin. When the center is at the origin, it's just R equals and what ring you're on. Okay, let's do another one. Okay, so for number 7, it's a rose, a flower. They're so cool that we can draw flowers on our calculators. There's an odd number of petals. So petals equals 5, and that's an odd number. So remember that means that your B value in the R equals A cosine or sine, depending on which one we're going to use, B theta. This B, if it's odd number of petals, then we leave it. If it's even, we double it. 2 times number of petals. Okay, so we know right now that my B equals 5. And then the A out front right here is the length of the petal. So we can just count 1, 2, 3, 4. So my A equals 4. And then we need to figure out whether it's going to be sine or cosine. And because we have one petal right here that's perfectly on a y-axis and none on the x-axis, then we're definitely going to use a sine. So my equation here is going to be r equals 4 sine 5 theta. Okay, number 8 is what we call the inner loop. It has that little baby cute loop on the inside. So remember, this is a limicon, and all the limicons come in the form of the r equals a plus or minus b, and then sine or cosine. So before I start, I kind of definitely pick out some things I know I'm going to get right. So definitely going to be, oops, that's a highlighter. Definitely going to be a sine equation because I'm on the y-axis. And because I just drew the positive y-axis, it's going to be a plus. Okay, so for our inner loop, we now know r equals a plus b sine theta. And so again, this is going to be a system of equations like before. So the whole length is 1, 2, 3, 4, 5, 6, 7, 8. So the whole length from the outside back to the middle is 8. So that means a plus b is going to equal 8. And this little baby inner loop right here is a length of 1, 2. So that means 2 equals, and I just need to write something down really quick. For the inner loop, a has to be less than b. So when I write this right here, I'm going to write b minus a equals 2 because b is going to be the bigger number. And so I can rewrite the system of equations. You can play the guess and check game. I just prefer to do algebra. So I'm going to do a plus b equals 8. Negative a plus b equals 2. I'm going to add these two equations together. 2b equals 10. So b equals 5. And you plug the 5 back in up there. 5 minus what makes 2? Well, that means a is going to be a 3. So there's your two numbers, and we can write our equation. So we're going to write down r equals, remember, a is the smaller of the two, so 3 plus 5 sine theta. Number 9 is a cardioid. It's a heart. It has this little, we call it a little dimple right there. So because it's a cardioid, and we're on the positive x-axis, we know it's going to be a cosine and a plus. So we're looking at r equals a plus b cosine theta. And when you have a cardioid, a equals b. So let's count how long this is. It goes 1, 2, 3, 4, 5, 6, 7, 8. Since it's 8 long, 4 plus 4 equals 8. So a is 4 and b is 4. So the equation here is going to be r equals 4 plus 4 cosine theta. Number 10, this is that flat side right here that we were talking about. So this is the indented loop, almost an offset circle, it has a little dent in it. So it's going to be a sine, and it's going to have a minus because I'm on this negative y-axis right here. For the indented loop, a is bigger than b. The long side is 1, 2, 3, 4, 5, 6, 7, 8. So a plus b has to equal 8. And the short side is too long. So since a is bigger, a minus b is going to equal 2. Add these two equations up. The b's cancel out. 2a equals 10. A equals 5. So that means b is 5 minus 2, which is 3. So our equation is going to be r equals 5 minus 3 sine theta. Okay, let's do the last two. So the last two are both roses. That makes things a little bit easier. So let's see. This one has B is equal to 5 petals. So we don't need to double it. That's good. And these petals are 1, 2, 3, 4, 5. Oops, I forgot a circle. 1, 2, 3, 4, 5, 6, 7 long. And I definitely have a petal on the x-axis, so I'm probably going to use a cosine, but that's a negative x-axis. So I think I'm going to have to make my A negative so that I can make it go on the negative side. So my equation for this is going to be r equals -7, the length of my petals, cosine 5 theta. And remember, because it's an odd number of petals, we don't double that inside number. Okay, this last one, a rose again. There are 7 petals. 1, 2, 3, 4, 5, 6. Yep, 7. So B equals 7. And the petals are 1, 2, 3, 4, 5, 6 long. And we have one on the y-axis, so it's probably going to be sine. And so I think my gut would be that it would be r equals 6 sine 7 theta. But I checked that with my calculator. And because there are 7 petals, this one would not have landed there. It would have actually landed up down here when you subdivided. And so to make that petal up on the top axis, we need to make the 6 negative. So it's going to be r equals -6 sine 7 theta. So now it'll be your turn to practice.